Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday Night Math Night. I am so excited that you're choosing to spend your Wednesday night here with me and the Learning Liaisons to prep for your math exam. When you prioritize yourself, it's amazing what happens when we just take this 1 hour to prioritize ourselves and really focus and buckle down and start to prepare or continue to prepare for that exam. It just makes us feel more comfortable. So before we get started, I always like to start with a question and a comment thread because it helps me get to know who's here with me right now. So if in the comments you could put where you're from and what test you're prepping for, that would be super helpful because it'll help me know, one, what tests are in the room right now, so Praxis, Texas, Florida, and also what subject area we're kind of studying for, and it helps me kind of curve my rabbit trail conversations that we have, because while the 10 problems that we have are set for tonight, the problems moving forward are not. And even though the problems are set, I can take each of these problems and kind of gear them down or gear them up based on who's here. So let me know where you're from and what test you're prepping for. Today is February 2nd, 2022, which is just such a silly date in my head. It's 2-2-22. And I know that Tuesday is coming up, which is 2-22-22. And I know a lot of teachers are excited about that. So today is another twos kind of day, which is exciting. So I'm from Central Florida. I am a math coach in Central Florida, and I just love spending my Wednesday nights with you guys doing math. So let's go ahead and get started. Oh, also, like Dr. A said, if you have questions while I'm solving these problems, please don't hesitate to ask. I'm more than happy to answer any questions that you have as I'm solving these problems. So don't hesitate to ask. And also, if there's certain types of problems you want to see in the future, please let me know in the comments. So if you're like, I'm studying for pre-K3 and I really want more symmetry problems, or I'm studying for high school math and I really want more coordinate geometry problems, please let me know. In fact, some of the problems tonight are from one of our Facebook users or Facebook friends. They commented and told me that they wanted to see functions and irregular area. And so we will see that tonight. Hey, Nicole. Hey, Teresa. Oh, Callie, you're not far from me. You're right up the road. You've got this. GK, you've got this. You are welcome. I'm glad that you're here. Nicole, I'm glad that you're here as well. Pre-K through 3. Awesome. Okay. This problem came from last week's problem set. And in fact, at the 2 people from Ocala, that's fun. In fact, I will drop the link later tonight for these problems. But if you downloaded these problems last week, then you'll recognize this problem. We just never got to it. So let's go ahead and read this problem. Sophia is solving an equation for the value of x and gets a result of 4 equals 4. What does this mean for the equation? This means that x equals a value of 4. This means that there is no solution. This means that there is an infinite number of solutions. This means she made a mistake and needs to solve the problem again to find her error. So if she's solving a problem and she gets 4 equals 4, the problem could look something like this. We'll start there. This is a very simple version. So if I add 3 to both sides, actually, no, I'm going to subtract 2x from both sides. I get -3 equals -3. But if we go back to that problem, 2x minus 3 equals -3 plus 2x. If we look at these values, really, they're the exact same thing. So if we think about this, the likely most common misconception for this one is going to be A. That's going to be the most common misconception, the most common error that people make is they're going to pick A. X is not going to equal 4 in this case. If X was going to equal 4 when Sophia solved it, she would literally get X equals 4. What this means, if we get something that looks like this, where we have a number equals a number, or X equals X, or something to that effect, we have an infinite number of solutions. Why is that? Because we have the same exact graph on both sides. So no matter what I put in for X, it will work. It'll be 4 equals 4, 7 equals 7, 12 equals 12. However, in a different kind of equation, like if I had 2x plus 7 equals 9, in that case, it matters what I put here because not everything is going to work. In fact, X is going to end up equaling 1 because 2 times 1 is 2 plus 7 is 9. But if I put 2 in there, 2 times 2 is 4. 4 plus 7 is 11. 11 does not equal 9. So this does not have an infinite number of solutions. It has one solution, where this is going to have an infinite number of solutions because I literally have the same thing on each side. So when Sophia solved the equation and she got 4 equals 4, that makes sense for it to be an infinite number of solutions because anything she puts into that equation is going to get an output that works. No solution would be if she was solving the equation like this would be a no solution. 2x plus 4 equals 2x minus 7. And again, this is a very simplistic version. If I subtract 4 from both sides, I get 2x equals 2x minus 11. If I subtract 2x from both sides, I get -11 equals 0. Is that true? No. And my goal was to find X. So that, if I had something like this would be no solution. So if Sophia solved an equation and got 0 equals negative 11, or she got 2 equals 5, there would be no solution. If she gets 3 equals 3, we have infinite solutions. And if she gets X equals something, there's one finite solution. It doesn't mean that she made a mistake at all. So that's how you can reason through a problem like this, is really using real numbers to kind of figure it out. This is a problem that really you could see on pre-K through 12. This is one of those problems that, depending on how it's worded, you really could see across the board. All right, let's move on to number 2. This is also a problem from last week's problem set, because we only got through about 8 problems last week. An artist has 240 assorted paintbrushes. Small paintbrushes make up a quarter of the artist's collection. There are 3 times as many small paintbrushes as there are medium paintbrushes, and the rest of the artist's collection are large paintbrushes. How many small and medium paintbrushes are there combined? Holy moly, we have quite the word problem here, quite the story problem. So let's go ahead and go through and really look at what information they gave us so that we can solve this problem. So we know that there's a total of, that's not a highlighter. We know that there's a total of 240 paintbrushes. This is how many she has total. So if I get a number that's bigger than 240, I know that I'm certainly doing something wrong. So we have 240 paintbrushes. What other information did we gather? We also found out that small paintbrushes make up a quarter of the artist's collection. So I'm going to go ahead, and I know that small, medium, and large are what she has, and it equals 240. Is this a super algebraic way to solve this problem? No, but I don't always solve problems super algebraically. If you want to solve it super algebraically, you can, but sometimes I just need a visual. So I have small, medium, and large paintbrushes, and all together it equals 240. And the small are a quarter. So if I divided my paintbrushes up into fourths, the small is going to be 1/4. So I could divide my 240 by 4. So 240 divided by 4 gives me 60. So I know I have 60 small paintbrushes. Now, if it said small paintbrushes make up 3/4 of the artist's collection, to be quite frank, I would have divided by 4 still, and then multiplied that number by 3, because I have 3 of those. I have 3/4, but that's beside the point. Small paintbrushes make up 1/4 of the artist's collection. Then we find out a key piece of information, which is where most of us are going to start checking out, because this is a really long problem. There are 3 times as many small paintbrushes as there are medium paintbrushes. And then the rest are large. So there are 3 times as many small as medium. So what does that mean? Does that mean we have more small or more medium? That's where we really have to start processing this information. There are 3 times as many small paintbrushes. So that means that I have more small paintbrushes than I do medium paintbrushes. There are 3 times as many small paintbrushes as there are large paintbrushes. So that means if I have 60 small, how many medium do I have? What times 3 is going to give me 60? 20. So let's look and see if this makes sense. There are 3 times as many small paintbrushes as large. So if I, or as medium. So if I multiply the 20 times 3, then I get 60. There are 3 times as many small paintbrushes as there are medium. So I have 20 medium. How many small and medium paintbrushes are there combined? I think I did something wrong here. And that's okay, because sometimes when we sit here and we think about it, we realize our answer is not in the answer choices. 60 plus 20 equals 80, and that answer is not in the answer choices. So let's go back and look at that sentence. There are 3 times as many small paintbrushes as there are medium paintbrushes. So if we multiply that 60 times 3, that's going to give us 180, and that wouldn't be correct, which means when I developed this problem, I didn't quite make the answer choices correct is what happened. So how many small and medium paintbrushes are there combined? 60 plus 20 is 80. So we're just going to do a little, and this happens sometimes, and that's okay. 80. So C is our answer. And that's not helpful for you when I make that kind of mistake, but it's always good for us to go back to the problem and make sure that we didn't make a mistake in our solving and that the mistake was in the test error writer person, which is me. So let's go ahead and move on to number 3. This is the last problem from last week, and then we're going to get into the irregular area that someone requested last week. So hopefully that someone is here tonight, because I did irregular area just for you because you had requested it. Select the equation below that has no solution. This goes right back to that first problem we did today. This goes right back to our conversation that we had here, where we were wondering, or we were talking about no solution, infinite number of solutions, and finite solutions. So let's go ahead and look at these problems and determine which one has no solution. Now, what did we decide for an equation to have no solution? If an equation has no solution, it means we're going to get something like 3 equals 7. Not possible. So I have to literally simplify each one of these equations to see which one has no solution. So let's go ahead and get started. Letter A, and I'm going to do each one in a different color so that we don't get our work confused. I'm going to use the distributive property. If you're not familiar with the distributive property, you should definitely become familiar with the distributive property. Distributive property says I can distribute this 3 all the way through, and I can distribute this -7. Do not miss that negative sign right there. That is a -7, even though we would read it 4x minus 7 times x plus 2. When I distribute, that negative goes with it. So I get 3x minus 15 plus 2x equals 4x minus 7x minus 14. When I simplify this, I'm only going to combine things that are alike. So 3x plus 2x is 5x minus 15 equals -3x minus 14. Add 3x to both sides, and I get 8x minus 15 equals -14. Add 15 to both sides. And I'm actually going to stop right there because I realize I'm going to get an answer. I'm going to get 8x equals 1. Divide both sides by 8, but I don't need to know the solution. I just need to know if there is a solution. And in this case, we have one solution, not no solutions. So A is out. Let's go ahead and do letter B. So negative 3 times x plus 1 equals 1 minus 3x minus 4. So I'm going to distribute. Negative 3x minus 3 equals negative 3x, and 1 minus 4 is negative 3. What do you notice about that? What do you notice about these two equations? They are exactly the same. So no matter what I pick for x, am I going to get the same thing? Yeah, if I pick 2 and I put a 2 here and a 2 here, I'm going to get the same thing on both sides. If I pick a 1,000 and a 1,000, I'm going to get the same thing. So this is going to have infinite number of solutions. So B is out. Because I could literally pick anything I want and it's going to work. Let's go ahead and do letter C. 2 times 5 plus 3x equals 9x plus 15 minus 3x. Distribute, and I get 10 plus 6x equals 9x minus 3x is 6x plus 15. And I kept the 6x's in the same spot just so I can compare these equations. Question, I want you to think about this. Am I ever going to get an answer that works? No, because no matter what I pick for x, on this side, I'm adding 15 to it, and on this side, I'm adding 10 to it, which means I'm going to get nothing that works. Let me show you how that works algebraically. I'm going to subtract 15 from both sides. 10 minus 15 is negative 5 plus 6x equals 6x. Subtract 6x from both sides, and I get negative 5 equals 0. Does negative 5 equal 0? Not on any planet I know of. Negative 5 does not equal 0. So this one is going to be our answer because it has no solution. Let's go ahead and look at letter D. At this point, I would have stopped on my exam and moved on. But let's look at letter D just for kicks and giggles. 4x minus 3y plus 5 equals 6x plus 8 minus 3y plus 12. I'm going to distribute this 6x. So I have 4x minus 3y plus 5 equals 6x plus 48 minus 3y plus 12. I'm going to add 3y to both sides. You'll see that what happens is it just ends up canceling out, which is good because otherwise we wouldn't be able to solve this if we had two variables. Then I'm going to get 4x plus 5 equals 6x. 48 plus 12 is 60. Yes. Subtract 5 from both sides. 4x equals 6x plus 55. Subtract 6x from both sides. Negative 2x equals 55. And I can divide both sides by negative 2. So here again, we have one solution. But again, I would have stopped after letter C because I would have gotten no solution and we would have been able to move on. All right. Yay, Nicole, I'm so glad it was you. Okay, somebody asked last week for irregular area problems, and I'm so glad you're here. Nicole is an excellent example of if there are problems that you want to see, let me know because I will incorporate them into our time together because this is really for you. It's not for me. I love doing this, but this is for you to study. So if there's something you need from me, you got to let me know. All right. Jason is trying to put tile down in a room that is shaped like the shape below. So this is the room that he has that he's putting tile in. And we disconnected because that happens about once every Wednesday, and that's okay. So the shape of the room is irregular. We don't have a formula for weird looking shapes, and that's okay because we can use the formulas that we know to find the area of shapes that we don't know. So in this case, I have this weird L-looking shape. So the question says, if each tile has an area of 12 inches squared, how many tiles will he need to fill up the entire room? Well, what do we know about a 12-inch square tile? That's a tile that's a foot. So really, that number is an extraneous number. It doesn't matter. We don't have to make any conversions because all of our units are in feet, and 12 inches squared is a square foot. So that means that I've got, if each tile has an area of, that should say 144. Here I go again. This is what happens when you have pregnancy brain and you're trying to write problems. This is what happens. This should say 144 inches squared because a tile that is a foot is going to be a 12-inch by 12-inch tile, which 12 times 12 is 144 inches squared, which is a 1 square foot tile. So in the original problem, it would say if each tile has an area of 144 inches squared, how many tiles will he need to tile the entire room? We have to be able to understand that this is a foot so that we can then just realize that number doesn't matter. So let's go ahead and transition into the problem. There are 3 ways you could solve this problem. First way, cut this shape into 2 rectangles. Find the area of this rectangle, find the area of this rectangle, and add them together. That's way number 1. Way number 2 would be to cut them into 2 rectangles going this way. Find the area of this rectangle, find the area of this rectangle, and then add them together. Way number 3 is going to be to find the area of this entire rectangle and then subtract this rectangle from the big rectangle. So we have 3 different ways we can solve this problem. I'm going to solve it by cutting this shape right here. If you would like to see me solve it a second way, please post in the comments and let me know which way you want to see me solve it as well. I'm going to start with just solving it like this. So what do I know about area of a rectangle? Area of a rectangle equals length times width. So I just know I need this times this. Well, for this larger rectangle, that's super simple. They gave us those measurements. So I can do 14 times 18. I'm going to use my handy dandy calculator because I have one. I know not everybody has one. So in that case, you would have to do this by hand, but that's going to equal 252 feet squared, which means there's 252 squares that are the size of 1 foot in this section. Because down here, there's going to be 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 14 more, and then 14 more, 18 times. That's why area is length times width. Now I'm going to go ahead and do this rectangle. So I need to know the dimensions of this side and the dimensions of this side because they didn't give us either of those. What did they give us that we haven't used yet, though? They gave us this 22. How could I use that 22 to help me? Well, if I know that this down here is 14, then I know that this up here is 14 as well. And so if that whole thing is 22, then 22 minus 14 can give me the missing piece. Like 14 plus what is going to give me 22, and that's going to be 8. 8 plus 14 is 22. So I know that that piece is 8. I can use that same process to find this side. I know that this whole thing is 18. So if that whole thing is 18 and this much of it is 7, because they gave us that over here, then 7 plus what is going to give me 18? 18 minus 7 is 11, which means this is 11. This is obviously not drawn to scale, and that will happen very often, where they will not draw it to scale on purpose. Yes, Nicole, you've got it. So 8 times 11 equals 88. And now I can just add the 88 plus the 252. And I get 340 tiles. So like I said, that's just one way we can solve it. There's 3 ways. We could have cut the rectangles differently, or we could have found the area of the whole rectangle and then subtracted that white corner out of it. And we all would have gotten the same answer. We all would have gotten 340. Excellent job. Now, sometimes composite shapes is what this is called, or irregular shapes will include triangles, trapezoids, half circles you'll often see half circles. So you have to make sure that you know those formulas if you don't get a formula sheet, because those are going to become super helpful when you're finding these kinds of area problems. All right. This is another composite area. So this is another irregular shape, but all I did was take it one step further beyond what we had here. Here we had 2 rectangles. So you could easily see this on a pre-K through 3 all the way through 12th grade. On this one, you would likely not see this on a pre-K through 3 or an elementary exam, because it requires the use of the Pythagorean theorem. However, with that said, we're going to get to a certain point in this problem where I'll say, this is where it splits off. This is where pre-K through 3, K through 6, you could see this problem as well. And then my middle school and high school GK math people, you'll see this differently. So to subtract, you multiply all the sides and then subtract the 7. Nicole, I'll come back to that question as soon as we'll go back. She's wondering, this is a great question, everybody. She's wondering, how would you solve this problem using the subtraction method? So I'm actually going to duplicate this slide. Okay, I thought I could duplicate this. Copy, paste. Sweet. I love when things work. So if you were, I'm going to do this super quickly. If you were to use the subtraction method, you would do 18 times 22, because those are the dimensions of the big rectangle that we have here. So I would do 18 times 22, and that would give me 396. Now, I'm not just going to subtract 7, because 7 is a linear measurement that just shows us this measurement right here. I would have to subtract 7 times whatever this measurement is, because remember, we're subtracting this entire rectangle, so we need to subtract the area of that rectangle. Well, what is the area of that rectangle? The area of that rectangle is going to be 7 times something. What is that something? Well, if this is 14, we already figured out in the other problem that this right here is 8. So 7 times 8, because this is going to be 8 as well, equals 56. So I would subtract 56 from that and then get the 340. Excellent question. Thank you for asking. All right, composite area problem 4B. A museum exhibit room needs to be recarpeted before the next traveling exhibit comes. So this is a museum exhibit room, because what other kind of room would have that shape? Let's be honest. The room shape and dimensions can be seen below. If the carpet costs $2 per square foot, how much will it cost for the museum to recarpet the entire space? So this is one of those problems where I have to come up with a plan because we've got a lot of different things. So we are recarpeting this. So the first thing I have to do is find the area of the shape, then the total area. Then I have to find the cost. So I've got two steps here. So in order to figure that out, we need to find the area of all of these little shapes. So I've got that shape. I'm going to do this in different colors so we don't lose ourselves. I've got this shape. I've got this shape. And I've got this shape. So let's start with the purple shape. 30 times 52 equals 1,560 feet. I'm always going to label what I have, especially when it's a problem like this, because we're dealing with dollars and feet, and I don't want to get my measurements mixed up. Then I'm going to move on to my pink shape. 10 times 48, length times width is how you find a rectangle, and that's going to equal 480. Then I'm going to move on to my triangle. What's the area of a triangle? Area of a triangle is 1/2 base times height. So in this case, my base is down here. My height is right here, and they gave us both of those measurements. This is 30. This is 48. So I'm going to do 1/2 times base times height, which is going to equal 720. That is where my pre-K through 3 and my K through 6 people are going to stop. That right there, the shape of the room would be that. We would not have the circle because the circle is going to require that we use the Pythagorean theorem. So my pre-K through 3 and my K through 6 people, your problem would stop right there. We wouldn't have a green shape. We would add the purple, the blue, and the pink together and then multiply that times 2 because it's $2 per square foot. However, my middle school and high school people, let's go ahead and keep going. In order to find the area of this green shape, we know the area of a circle equals pi r squared. And this is a half circle, so we're going to divide that by 2. But in order to do that, I need my radius. And they didn't give us the radius. But what we do have is a right triangle. And so we can go ahead and use the Pythagorean theorem to find the diameter, which means we can then find the radius. So I have my right triangle, 30 and 48. So a squared plus b squared equals c squared. C is always going to be your hypotenuse. So 30 times 30 is 900. 48 times 48, ooh, I think I pushed the wrong button, is 2,304 equals c squared. Add that to 900 and we get 3,204 equals c squared. Square root both sides and we get c equals 56.603. That is the diameter. Do not confuse that with your radius. We just found the entire length of that triangle hypotenuse. I have to divide that by 2 to find my radius. So if I divide that by 2, I know that my r is going to equal 28.30. I can square that and I get 801. So the area of this is going to be 3.14 times 801 divided by 2. Punch all of that into my calculator. And I get 1,257.57 feet. Remember, these are all in feet. Now I'm going to add all my feet together. Why? Because I'm trying to find the area of this shape first. I still have not found the area of this shape. So let's go ahead and add 1,560 plus 720 plus 480 plus 1,257.57. Again, I'm going to use my calculator so I don't make a silly error. Plus 720 plus 480 plus 1,257.57. That gives us 4,017 and 57. What does that number represent? That number is still feet. I've done nothing with the money. Don't automatically pick B because you see that as an answer. We are not done yet. All we did was add all the feet together. Now we go back to the problem and we see it says, if the carpet costs $2 per square foot. So now for every square foot, I'm paying $2. So I'm going to multiply that times $2 and I'm going to get 8,035 and 14 cents, which is C. Does that process make sense? If you have questions, please don't hesitate to ask. And let's keep going. That was a lot of steps for one problem. Let's go ahead and keep going. Lines P and Q. This is a fun one. I'm excited. Lines P and Q intersect at point X, Y at a 90-degree angle. If the slope of line P is this, what is the slope of line Q? So this is one of those kinds of problems where people look at this and they have the foundational knowledge to solve it, but they automatically give up because they don't recognize those symbols. Do not do that. All this is saying is that we have a graph and we have a line P and we have a line Q and they intersect at point XY. So we're going to call this XY at a 90-degree angle. So we know that this is a 90-degree angle. What do we know about lines that, and the relationship of two lines when they intersect at a 90-degree angle? What is that called? That is called perpendicular lines. These are perpendicular lines. If they were parallel, they would never intersect. And if they were just intersecting lines, they wouldn't intersect at a specific degree. So these are perpendicular lines. What do we know about the slope of perpendicular lines? The slope of perpendicular lines, the relationship is a negative reciprocal. Negative reciprocal. What does that even mean? That means if the slope of line A is 2/4, then the slope of line B would be -4/2. Negative literally means I'm just multiplying 1 by a negative. Reciprocal means I'm flipping the fraction. Here's where people get caught up. What if the slope of line A is just 3? Well, you can always put 3 over a value of 1, and that way when you flip it, it becomes negative 1/3. Okay? So what they've told us in this problem is the slope of line P is this. So then if I know that the slope relationship of perpendicular lines is the negative reciprocal, and this is line P, then line Q has to be the negative version of it and the flipped version of it. That's all they're asking us to do. This problem should take you 10 seconds. You should be able to read this problem, know the relationship of perpendicular lines, and immediately see it. There's nothing to solve here. So this is one of those time saver problems. You either know the relationship or you don't. So if you know it, don't give up and shut down because these symbols look weird. Think about what the problem is asking you, because usually the problem is asking you about something that you already know. Excellent job processing through that problem. Let's keep going. A student in 2nd grade, pre-K through 3, K through 6 people, this one's for you, was asked how many tens are in the number 487. The student responded and said that there are 80 tens in the number 487. Where does this student's misconception lie? The student does not understand what digit represents each place value. The student does not understand the difference between the digit and the value the digit represents. The student does not understand how to read a 3-digit number. The student has no misconception and is correct. So let's pause and think. Does this student have a misconception? Before we even move forward, does this student have a misconception? We have the number 487, and they want to know how many tens are there. Well, in this number, we know we have 4 hundreds, 8 tens, and 7 ones. 4 hundreds, 8 tens, and 7 ones. So yes, absolutely, this student has a misconception. They are not correct. So automatically, I'm going to cross off the letter D because the student has a misconception. We just have to figure out what kind of misconception. If we think about this number, we know we have 4 hundreds. I'm going to go ahead and draw this number. 300, 400, 10, 20, 30, 40, 50, 60, 70, 80, 81, 82, 83, 84, 85, 86, 87. How many tens are there? There are 8 tens. There are not 80 tens. There are 8 tens. If I count by tens to get to the number 80, 10, 20, 30, 40, 50, 60, 70, 80, how many fingers did I use? 8. There's only 8 tens. So the student has a misconception. Where does the misconception lie? Well, the student does not understand what digit represents each place value. Well, that's not quite where their misconception is. The student doesn't understand what the place value means. The student does not understand how to read a 3-digit number. We don't know that. The student didn't read the number for us. So letter C is out. The student does not understand the difference between the digit and the value the digit represents. There's our answer. Because the student thinks that because this is an 8, that there are 80 tens because it equals 80. The value of that digit is 80, but there's only 8 tens. Now, my friend who just commented, I don't know what your name is. I just see your YouTube name, the male. Yes, there would be 48 tens. You're right. Like if we were to do it that way and get rid of the hundreds, we would have 48 tens or 4 hundreds and 8 tens if we were to convert them, because we can write a number in multiple ways. So you're absolutely right that 48 tens, but that's not what the question asked. So you are good. So yeah, letter B would be correct because they don't understand the difference between what 8 tens equals 80, but it's not 80 tens. Absolutely. All right, that was a great pre-K through 3, K through 6 problem. We are going to skip that one because I don't have enough time to fully explain it. So we're going to do this one. We're going to do problem 11 because we're running out of time very quickly, and we'll save problems 8, 9, and 10 for next week. All right, which of the following graphs represents a function? And Nicole, this kind of goes back to what you were asking for with input and output. So a function is defined as having only one. I always mix this up when I speak it. So let's do this instead. Let's look at a function has to pass the vertical line test. And if it passes the vertical line test, that means it can only have one y for every x. Don't get that mixed up. It can only have one y for every x. So for this x value right here, we actually have 2 y values. So because that vertical line hit the graph in 2 separate places, this would not be a function. Let's take a look at letter B. If I draw vertical lines through this graph, I'm only going to ever hit it once. Now, be careful because it looks like this goes straight up, right? It looks like at some point I'm going to draw a vertical line and it's going to go through the entire thing. This is called a rational function, and you don't have to know that, but by process of elimination, you would know that this is going to be the correct answer. It actually never gets completely vertical. It gets very close to being completely vertical, but it doesn't get completely vertical. So this is going to be our answer. But like I said, if you get confused by that, this is very obviously not a function because it passes through 2 times in multiple places. And this is very obviously not a function either because it's going to cut through that circle 2 times on that vertical line. So because the other 3 answers are very obviously not functions, we can assume that it's B. And like I said, that's a rational function, which means that when I draw those vertical lines through the graph, it hits only 1 time. So a function is defined as for every x, there is exactly only 1 y value. Now, I don't ever memorize that. I just use my vertical line theory. So if they gave us a table of values, a bunch, like for A, B, C, and D, and they said, which one is a function? Again, I don't memorize it. I'll just go 2, 3, 3, 4, 0, 1, 1, 2. I'll just quickly graph it in my head over 2 up 0, over 3 up 1. That was a poor example. Over 3 up 4. And over 4 up 2, I see that I have a vertical line issue, so that would not be a function. So sometimes I'll just take the extra time to quickly graph it if I can't remember this statement right here. So basically the graphs that aren't a function look like a circle or an O. Not necessarily, because this one right here doesn't look like a circle or an O, but it's not a function either. It looks like a sideways U. It's a sideways parabola, and it's not a function either because I cross it 2 times. So, and then sometimes we'll have graphs that are discrete, which means that they don't connect, and it'll look something like this. And we know that that's not a function either because, again, when we draw a line through it, it doesn't work. So yes, You're absolutely right that a circle or an O or an ellipse is definitely not going to be a function, but those aren't the only kinds of non-functions. There's a lot of other different kinds. Excellent question. All right. That's all we have time for today. And I have a kind of sad announcement. I will not be with you guys for the next 2 weeks. My amazing colleague Priya will be taking over for the next 2 to 3 weeks because we are being induced on Friday and having our baby. So I will not be with you guys for the next 2 to 3 weeks. Priya will be taking over, and then I will join back with you in a couple of weeks once we get settled. Nicole, I will absolutely pass that along to Priya so that she can add those kinds of problems into her problem set, because that helps her as well. So thank you so much. I'm going to turn it back over to Dr. A, and I will see you guys in a couple of weeks. But don't worry, Wednesday night math sessions are still going to happen, and you guys are going to be in the best of hands while I am out. And like I said, Nicole, I will make sure that I pass that message along so that she can add those kinds of questions in as well. All right. Have a great night, and I will see you guys in a couple of weeks, and Priya will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.